Hello, this is Mr. Standerson, and in this short video I want to talk you through the process for finding both acceleration and also displacement from a velocity time graph. Thanks.
The first example is asking us to find the acceleration between 2 to 5 seconds. I noticed when I section off this that it actually goes from 2 to 6, but it's the same slope. And remember, slope of a velocity time graph is equal to the acceleration of that segment. So I'm going to want to look for the slope of that section on the graph. Using my rise over run, I'm going to look closely to figure out that it rises 2 meters per second and the run is 4 seconds. So 2 and 4 are the numbers I'm going to use. Plugging that into my slope equation gives me 2 over 4 or 1/2. Now the units are meters per second over seconds, our unit of acceleration. Now thinking about displacement, we're going to want to figure out the area under the curve. And displacement is going to tell us not the total distance traveled, but the total movement from the start. So we're going to find the area under the curve of their velocity time graph. I'm going to redraw a few things here to help us. I'm going to split this into two chunks. The first chunk is a triangle, and then I'm going to find the area of the triangle added to the area of the remaining chunk, which is a rectangle. I'm just using simple area formulas here. We know the area of a triangle is 1/2 base times height. So I can substitute in what I know. I'm counting over 4 units and up 2 units. So that gives me an area of 4 plus the area of a rectangle is length times width. So now I'm going to look at my chart, my graph, and figure out the length is 1 and the height or the width is 2. So that gives me 2. Adding these together will give me the total area under the curve. When you're adding this together, be very careful of any positive or negative area that you might have calculated. In this case, both are positive, so that's okay. We're just going to add them together. However, if one is positive and one is negative, you're going to have to account for that in your final addition or sum of all of the areas. So in this case, we're just going to add 4 plus 2, both positive, and that equals 6 meters. So my displacement would be 6 meters from my start. In the next example, I'm going to repeat the process. Acceleration using velocity and time is the slope of the velocity of time graph. I'm again looking between this segment, 2 to 5 seconds, and I notice that the slope is 0. 0 over 0, rise over run, so I really don't have an acceleration during that amount of time. I'm also going to then check the total displacement. So in this example, I have two triangles. I'll use 1/2 base times height. For the red segment, it actually goes below the axis. We're going to count that as a negative. So that would be a negative displacement. The other blue one goes above. That's going to be a positive. When we combine these together, we're going to want to combine them accordingly. So I get -2 for the red segment. It's the same triangle. We just are now in the positive. So I'm going to use the same substitution, and I get a +2. As you could think, when we combine these together, the displacement is actually going to be 0. +2 and -2 add to 0. So this object did not change its position from where it started. So we could say something like when it's talking through this, there was a change in direction. So the object at the start might have been moving toward the origin or towards where it started, and then it stopped. So this place right here, where the velocity is 0, it would have stopped during that section. But then it's also changing direction. Remember, it started negative, so it started moving towards, it stopped, then it's going to switch around and go back, moving away in the opposite direction in the same amount of distance or displacement. So it actually cancels out. Hopefully this makes sense. Please use these techniques on the remaining questions in your activity. Thank you. Have a great day.